then the EMF induced in the secondary coil is called mutual inductance between the pair of coils. If induction has to happen, there should not be any physical contact. It is the phenomenon of inducing EMF. No exaggerations. It is again one another method is directly proportional to rate of change of magnetic flux. But if galvanometer shows deflection, there means there has to be some current. Increase the strength of the current in the primary coil. Deflections in the galvanometer is more. Hello students, this is SD Sir again from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. What did we study in our previous session related to electromagnetic induction? Yes, we studied a very beautiful phenomenon called self-induction and a few mathematical concepts related to the phenomenon. So, can you all recall back the definition of self-induction? We told it was a phenomenon where an EMF is induced in a coil. I am inducing an EMF in the coil. How? By changing the current flowing through the same coil, and therefore we also told it is a property, behavior of the coil to oppose the growth or decay of current in it. Now, what is that I have in store today? A very much related phenomena, a topic similar to the earlier one, what we call as mutual induction. So, my dear students, in today's class, I'll discuss about the physical meaning of mutual induction and again several mathematical concepts related to the phenomenon of mutual induction. So to begin with, let us understand the textual meaning, the biblical meaning of the word mutual induction. Religious agi mutual induction andrenu anta artha madಕೊಳ್ಳೋಣ. Primarily, the word mutual refers to something called in between, related to, or the moment I say mutual, there has to be a pair, mutual understanding between two people, mutual consent appreciation by two people. So the very word mutual refers to a pair or in between something. Now we are trying to understand something called mutual induction. Fine. The phenomenon in which an EMF is induced. Again, it is the phenomenon of inducing EMF. No exaggerations. It is again another method of inducing EMF. How? Inducing EMF in one coil. I am inducing EMF in one coil by changing the current in the neighboring coil. Very beautiful. ಪಕ್ಕದ ಮನೇಲಿ ಟಿವಿ ಆನ್ ಮಾಡಿ ನಾವು ನಮ್ಮ ಮನೇಲಿ ಟಿವಿ ನೋಡೋದು. We are inducing EMF in one coil. How? By changing the current flowing through the neighboring coil. That is what is called mutual induction in between a pair of coils. See, very much similar to self-induction. But what happened in self-induction? EMF was induced in a coil. How? By changing current through the same coil. ಅದಕ್ಕೆ ಅದನ್ನ ಸೆಲ್ಫ್ ಇಂಡಕ್ಷನ್ ಅಂತ ಕರೆದ್ವಿ. Here it is mutual induction. Mutual, ಇಬ್ರು ಮಧ್ಯ, in between, ಎರಡು ಕಾಯಿಲ್ಗಳ ಮಧ್ಯ. So the phenomenon, the process where EMF is induced in a coil, I am inducing EMF in a coil. How? By changing the current in the neighboring coil is what we call mutual induction. Now, how do I practically assess the phenomenon? Let us try to understand better what and how mutual induction takes place. Now, I have a pair of coils. One I call as P and the other one I call as S, which are placed close to each other. P and S are two coils. ಎರಡು ಕಾಯಿಲ್ಗಳು ಬೇಕಲ್ವಾ? Because I need mutual induction to happen. I need to induce EMF between a pair of coils. So P and S are two coils placed close to each other, but again not in physical contact. 101 times I have told, if induction has to happen, there should not be any physical contact. So P and S are the two coils placed close to each other. Now, the coil P, as you can observe in the circuit, the coil P is connected in series with what? With a battery and a tap key. So this is the tap key and this is the battery. So the coil P is connected in series with a battery and with a tap key. I have told in my previous discussion, key behaves as a switch. Close the key, circuit is closed, current flows through the coil. Open the key, switch off mardange, circuit is open, there is no flow of current. And why do I require a battery? Yes, to apply some potential, to see there is current flowing through the coil P. And the coil S is connected to a galvanometer G. So you can see S is connected to a galvanometer G. So interestingly here, we call P as the primary coil and S as the secondary coil. P is denoted by the term primary coil and S is denoted by the term secondary coil. Now, when the key is pressed, as you studied in your self-induction, a tap key na press martidini, I am closing the tap key, I am closing the circuit. What should happen? The current flowing through P increases. Initially, before the switch was on, there was no current flowing through P. Now, the moment I have closed the tap key, the moment battery is switched on, slowly current flowing through the primary coil increases. So, if key is closed, I, that is current flowing through the primary coil, increases. Adane em karidvi? There is growth of current in the primary coil. Now what happens? Beautiful. This growth of current or increasing current through the primary coil will change the magnetic flux linked with the secondary coil. Mutual, in between, a pair of coils. Current flowing through the primary coil will change the magnetic flux linked with the secondary coil. How did I come to know? The moment current started flowing through the primary coil, galvanometer in the secondary coil showed some deflection. Here I have no source of current, but if galvanometer shows deflection, there means there has to be some current, some induced current. So from where do I get this induced current? Magnetic flux across secondary has changed, which has induced EMF. And who is the cause for that? Current increasing in the primary coil. So you can beautifully see a phenomenon is happening between a pair of coils. Current flowing through the primary coil is changing the magnetic flux linked with the secondary coil. Hence there is induced EMF. Hence current is induced in the secondary and galvanometer shows deflection. Very beautifully, there is mutual induction. The next case, if I open the circuit, open the key, current decreases in the primary coil. Now the tap key is opened, the switch is opened, circuit is opened, there is decay of current. From maximum, slowly the current goes on decreasing. This decrease of current in the primary coil again changes the magnetic flux linked with the secondary coil. Magnetic flux has changed, EMF is induced, and hence current is induced in the secondary. So you can very clearly understand, my dear students, the current which is growing in the primary coil, which is increasing in the primary coil or decaying in the primary coil, is changing the magnetic flux linked with the secondary. Hence EMF is induced. And again, according to Lenz's law, direction of induced EMF in the secondary opposes the growth or decay of current in the primary coil, and this is what we beautifully understand as mutual induction as contrast to your self-induction. Now, coming to the mathematical understanding of mutual induction. As we studied coefficient of self-induction, now we understand coefficient of mutual induction. Exactly on the same basis as we studied our self-induction. Now, if phi is the magnetic flux linked with a which coil? Secondary coil. Very good. So phi is the magnetic flux that is linked with the secondary coil. When a current I is flowing through the primary coil. Very good. So phi is the magnetic flux linked with the secondary coil when the current flows through the primary coil, then again phi is proportional to I. Andre, increase the strength of the current in the primary coil. Deflections in the galvanometer is more, which means change in the flux across the secondary is more. Reduce the current in the primary, change of magnetic flux across the secondary is less. So we say phi is proportional to I. How do I eliminate proportionality? Introduce a constant. And the constant I introduce is M, which is called coefficient of mutual induction or mutual inductance of the pair of coils. Now, how do I define M? To which I apply unitary condition. If I is 1 ampere, then phi is equal to M. Here, if I assume I is 1 ampere, then phi becomes equal to M, which means mutual inductance between a pair of coils is numerically equal to the flux linked with the secondary coil when the current flowing through the primary coil is 1 ampere. Please to understand, only when the current flowing through the primary coil is 1 ampere, flux across the secondary coil is equal to M. So, mutual inductance between a pair of coils becomes equal to phi when the current flowing through the primary coil is 1 ampere. Now, again, the Aleta alternative definition for mutual inductance from Faraday's second law. Again, Faraday's second law stated E is proportional to d phi by dt, magnitude of induced EMF is directly proportional to rate of change of magnetic flux, or E is equal to minus d phi by dt. Why negative sign? Validity of Lenz's law, direction. Or phi is equal to M into I in this case. M is a constant. It's a coefficient of mutual induction. I take out M. What survives? Di by dt. Now, as we did earlier, if di by dt is 1 ampere per second, this di by dt, andre, if the rate of change of current there across the primary coil is 1 ampere per second, then the EMF induced in the secondary coil is called mutual inductance between the pair of coils. See, only if di by dt is 1 ampere per second, E is equal to M. That is, the mutual inductance between the pair of coils is equal to the EMF induced in the secondary coil only when the rate of change of current across the primary is 1 ampere per second. And a SI unit of mutual inductance is also Henry. So self-inductance and mutual inductance, both of them have a unit called Henry. So very clearly, students, in today's session, I have described mutual inductance, how EMF is induced between a pair of coils, more precisely between a primary coil and secondary coil. What is that I have to do? I have to simply change the current flowing through the primary coil. EMF gets induced in the secondary. Hope you are thoroughly practicing the sessions. Very important for my next chapter. In my next session, we will cover up and seal this topic by studying AC generator. Until then, stay safe. Thank you.